Okay, so today we're working on unit 12.1. You guys are going to test on this during senior finals. So senior finals are May, like 2 weeks, right? A week from Friday and Monday. So I'll talk to you guys later about your schedule and all that goofy stuff. But we're working on defining sequence and series. Sequences and series. Defining sequences and series. Okay, so a couple of small things you need to know. The actual textbook definition of a sequence is a function. Does anyone remember what's a function? Something you plug into. Okay, a function whose domain is a set. Function whose domain is a set of consecutive integers. So basically a sequence is like a formula that you're given and you plug in consecutive numbers. Okay, so what we're going to work on today, you're going to plug in 1 through 5. Okay, so you're not plugging in any fractions, no decimals, nothing like that. You're just plugging in 1, then 2, then 3, then 4, then 5. Easy way of saying a sequence is basically it's just a list of numbers. So that's the technical definition, but really it's just a list of numbers. So your instructions for the first part today are going to ask you to write the first 5 terms of the sequence. Write the first 5 terms of the sequence. So for number 1, there are 6 examples today. Excuse me. For number 1, a sub n, and that is subscript. So a sub n equals 2n plus 5. So essentially, this is the formula that we're plugging into. So we're going to plug in for n. And I want you to find the first 5 terms. So you're going to plug in a of 1. So we're going to plug in 1 for n. So 2 times 1 plus 5. 2 times 1 plus 5 gives us basically 2 plus 5, so your answer is 7. And then I want you to plug in all the way through 5. I know this is kind of tedious, but it's actually really simple. Okay, so plug in everything through 5. Say it again, Haley.
Is this going to be like a time-consuming thing? It's easy.
It's easy. It's just kind of, it's repetitive. It's not horribly time-consuming, but a little bit. So you guys should be able to plug these in. You don't have to show all the work. So if I plug in a sub 2, what would I get? Where's my? What do I get when I plug in 2? Nine, right. Okay, what do I get when I plug in a sub 3? Anyone? 11. What about when you plug in 4? 13, and then 15. Okay, so there's a sequence here. Eventually, we are going to get just this sequence, and you're going to have to go backwards and tell me how to write the formula. But for today, all you're doing is just plugging things in. So it should be super, super simple for you. Okay, that's your answer. That's it. Okay, technically you'd put parentheses, or excuse me, commas in between these, so 7, 9. But you can leave them just like that as your answers. I don't really care. Okay, try another one for number 2. F of n, so f parentheses n. This is just another way to write the same thing. Okay, you can have them written like that. You can write a function of n, does not really matter, equals -3 in parentheses to the n minus 1 power. -3 to the n minus 1 power. And again, I want you to find the first 5 terms, so plug in 1, 2, 3, 4, and 5. So start with f of 1, so that's -3 to the 1 minus 1 power. So -3 to the 0 power gives us what?
0.
Anything to the 0 power equals 1. Then plug in 2, 3, 4, and 5. You should be able to do those on your own. So when you plug in 2, f of 2 gives us what, Trevor? Negative 3. Okay, what is f of 3?
27.
No.
Oh, 9.
Positive 9. Okay, f of 4? Negative 27. And f of 5? Positive 81. So it is okay for it to go positive, negative, okay? It is totally possible to be switching between positives and negatives. Anyone have questions yet?
No.
Should be fairly simple, right? I hope. Okay, let's try another one. This will be the last one of this kind. Example number 3. Let's go a sub n equals 2 to the n power minus 3. The minus 3 is not in the exponent. Okay, it is on the ground level. So again, first 5 terms in the sequence, so you're going to plug in 1 through 5. So 2 to the first minus 3 gives us what? Negative 1. Okay, and then again, plug in all the way through 5. So what happens when we get 2 squared minus 3? Positive 1. 2 cubed minus 3? Positive 5. 2 to the 4th minus 3? What is 2 to the 4th?
27.
What's 2 to the 4th?
16.
16.
Oh, whoops.
Minus 3 is 13. And what's 2 to the 5th?
32.
32 minus 3 is 29. Okay, so these are your answers here. The actual list of numbers that you get when you plug something in. Anyone have questions? So this should be pretty simple. Okay. Next thing we're going to do is something called using summation notation. Using summation notation. So just by the title, what do you think we're going to be doing if it has the word sum in it?
Adding.
Adding, okay? Summation notation, you need to know, is used to write a series. So this whole unit is all about sequences and series. Sequences are what I just showed you. It's just a list of numbers that you get from plugging something in. A series is the result when terms of a sequence, are added together. So like I said, a sequence is when you get a formula or an equation, you plug things in, and it's the list of those numbers. A series is when you add all those numbers together. So this is going to ask you to find the sum of the series. That's what your instructions are going to say. Find the sum of the series. Okay, and this is going to look a little funny, but I'm going to explain to you guys what this means, okay? Summation notation looks like an E, kind of written like that, or almost like a backwards M, or a sideways M. Okay, that is summation notation. You can't write like a normal capital E. That is what summation notation needs to look like. On the top, there's going to be a 5. Underneath, it's going to say I equals 1, and then next to it, I squared. So I'm going to tell you what these mean now. The bottom number is the first number that you plug in. Okay, the bottom number is the first number that you plug in. This middle part is what you plug into. That's like the formula that you plug into. And the number on top is the last number that you plug in. So essentially, this is telling me to plug into this equation, into I squared, starting with 1 all the way up through 5. So we're going to plug in 1, 2, 3, 4, and 5. Okay, you only plug in whole numbers, so no fractions, no decimals. And then since this is summation, that means add them all together. So that is going to equal 1 squared plus 2 squared, 3 squared, plus 4 squared, and all the way up to 5 squared. This just happens that we're plugging in, or that we're going to add up 5 different things. Sometimes it might start at 0 and go to 3. You could start at 20 and go to 23. 25, does not matter, okay? You can also start at negative numbers, okay? So you can start at a negative, go to a positive. It is not always going to be 1 through 5. This just happens to be because I'm trying to make an easy example for you. So if you plug these in, this is 1 plus 2 squared is 4, plus 3 squared is 9, 4 squared is 16, 5 squared is 25. You can use calculators on this unit, just so you know. And if you add all those together, you should get an answer of 55. Trust me, I already did it on the calculator. That's your answer. So a sequence is just plugging them in and writing the list with commas in between. A series is when you plug them in, add them all up. That's it. Questions on how I did that? Okay, let's try another one. For number 5, I want you to find the sum of between k equals 0 and 4 of the equation 3k squared minus 7. Excuse me. Sum of between 0 and 4 of 3k squared minus 7. So you're going to plug in every single one of these numbers from 0 all the way up through 4. So 3 times 0 squared minus 7 is 3 times 1 squared minus 7. 3 times 2 squared minus 7 plus 3 times 3 squared minus 7 plus 3 times 4 squared minus 7. Sorry, I kind of ran out of room there. So if we plug this in, 0 squared gives you 0, times 3 is 0, 0 minus 7 gives you negative 7. Plus 1 squared is 1, times 3 is 3, minus 7 gives you negative 4. 2 squared is 4, times 3 is 12, minus 7 gives you 5. 3 squared is 9, times 3 is 27, minus 7 is plus 20. And finally, 4 squared is 16, times 3 is 48, minus 7 is 41. Add all those together, you can use a calculator. That also happens to be 55. Don't think that you're always going to get that answer. I just happen to have 2 random examples that both got 55. It's not like a special number that you're going to get a lot. Sorry. Questions? So these are just time consuming. They're not difficult. Okay, they're just kind of intricate because you have to show work. And for my class specifically, you have to show work. Have to. Not an optional thing. Okay, last one. Yeah, you. Last one. Sum of between k equals 4 and 8 of 3 plus k squared. So here, what's the first number that I'm going to plug in? 4 squared, exactly. So you start at 4, go all the way up through 8. So 3 plus 4 squared, plus 3 plus 5 squared, plus 3 plus 6 squared, plus 3 plus 7 squared, plus 3 plus 8 squared. Make sure you're doing order of operations correctly, so you have to do the square part first. So what's 3 plus 4 squared? 19 plus 3 plus 5 squared, 28. 3 plus 6 squared, 39. 3 plus 7 squared, 52. And finally 3 plus 8 squared, 67. Plus 3 is 67, Damon. Add all those together and you should get an answer of 205. That's your answer, 205. Hey, homework for this is going to be, we're actually going to work out of our actual math book for this unit, believe it or not. You're doing page 798. You are doing numbers, this is not very much, 3 through 14 and 45 through 50. Okay, 3 through 14 and 45 through 50. Anyone have any questions? Should be pretty good.
What is that little E thing